personally fascinated by the serverless as a concept because you need to think about, underlying stuff, but it actually brings some challenges, and I would like to discuss them today as well. Can you give our listeners some bits of info about yourself?
Yes, sure. So my name is Luca. I'm a serverless specialist, solution architect. I'm based in London, and it's 3.5 years that I'm working for AWS. Before joining AWS, I was vice president of architecture for a company called DAZN, DAZN, that is a live sports streaming platform that is currently global. And there, basically, I had the pleasure to design all the distributed system and the micro-frontends approach. So we had the distributed system end-to-end. I'm an author, a published author for O'Reilly and for A-Press. I'm working on a third book right now. I'm a YouTuber, content creator, and also an international speaker. I had the pleasure to speak in several stages, from Japan to Silicon Valley, keynotes, workshop, live session, wherever was, let's say, available. I pick it up because I want to give back a lot to the community. I grew up through the community. I'm a self-taught, and therefore usually I engage a lot with the community. It's something that provides me a lot of joy, and I hope that I can share what I've learned in the last 20 years in the tech industry as much as I can.
Wow, that's great. Thank you very much. You mentioned the YouTube channel. So
yes.
what it's all about?
So in my YouTube channel, I usually talk about software architecture. I talk about productivity tips. Currently, I'm working on a second brain video where I explain how I design my second brain and how I think is a fantastic tool for everyone out there in order to offload your mindset with all the ideas and thought and things that you have to remember in general, and instead leveraging, let's say, a digital asset like Notion in this case for me, where I use that where I free up my mind and I use my brain for connecting more than for remembering. That our brain is designed for that.
Okay. So it's like kind of a knowledge base that you can use to.
Correct.
Okay, great. Yeah, that's a separate topic. Maybe we can have another encounter and talk
Absolutely.
about knowledge bases.
Happy to.
Yeah, sounds great. Like you sound like a very solid profile, like books published, like international speaker. That sounds great. Something. What are your books about?
So I have currently one book on reactive programming for front-end architectures, where I analyze basically different architectures over there. And then I wrote one of the few books about micro-frontends, so distributed system on the front-end, where there I basically helped roughly 100 teams worldwide, let's say, embracing this approach alongside the microservices approach for having distributed system end-to-end.
Usually when we talk about distributed systems, people think about, consensus algorithms and the databases. So like distributed systems for front-end sounds interesting, let's say. What is the biggest challenge for the front-end regarding distributed systems?
We just had the second edition of the Micro-Frontends conference, where I was describing, let's say, the concept of Micro-Frontends platform, similar to what we have when we talk about platform teams in distributed system in general. But the main challenge for me is organizational and changing the mindset of people, because every developer thinks in components on the front-end side. But the reality is a component is leaking its domain to its container. So it's just providing an abstraction for common functionalities, but the container of the component knows how it should behave in a specific context. With micro-frontends, we are instead encapsulating the context inside a chunk of the view, or the entire view, depends how you want to slice. And there you are going to provide, let's say, an independent let's say, artifact that is deployable without coordination across the other teams. The whole idea is trying to foster the same concept of microservices, where you want to have independent teams, where you want to have reduced external dependencies, where you want to change a portion of the system without affecting the rest of the system. And it's a different concept that sometimes is hard to grasp at the beginning for front-end developers, because we were used to define, let's say, a common state management for everything, and then having different components that they were fetching from this state management. In this case, instead, there is a bit of more thought and preparation in order to identify what are the boundaries of the system. But when you combine micro-frontends alongside microservices, then you start to have teams that are cross-functional teams that are really independent. And the whole point of distributed system for me, or let's say one of the most important one, is enabling the organization to move faster and let's say having a fast feedback loop, potential drift towards a direction or another one. And therefore we express that a chunk of the system is owned end-to-end by one team or a couple of teams. That will enable them to become, let's say, domain experts and take the right decisions into that. And obviously for the organization means decentralization. So decentralization not only on the technical side, but more importantly on the mindset. Because if we decentralize and we provide the possibility inside certain guardrails, obviously, to the developers to take their decision, we move faster. And that's the whole point of, let's say, creating a distributed system, in my opinion.
Okay, so everything for the time to market, essentially.
Yeah, time to market, and also the possibility to reduce the external dependencies. I was a developer for a long time, and I remember when you always have like, oh, I need to, for deployment, I need to speak with that team that has a complete different backlog, and they need to coordinate with that. So I need to start to discuss. There was a lot of friction back in the days. Now what we want to achieve is the fast flow, and we want to achieve fast flow in order to, let's say, have more feedback loop from the consumer towards the product and therefore to the developers. And I think this is something that is very important, that we don't focus only when we talk about architecture to the technical implementation, because it's just a one third of the picture. Culture and organization structure and are the other two. And I believe that we cannot forget about them.
Yeah, true. Okay, let's talk about the serverless. So yes. Yeah, the goal of the interview was to think about like where are we going with this serverless thing. But I think what we need to start with is actually understanding why we have serverless in the first place. So how can you please describe like what's the value of serverless solution we got?
Of course. So in we announced in AWS, let's say, the idea of the first serverless service that was AWS Lambda functions. And it was November when there was the reinvent. And then since then, basically, this year we are, let's say, cheering up because in November will be the 10th anniversary of functions of the first.
Oh my God, already a decade.
Yes, already a decade.
Okay.
It's been a while. And the idea behind serverless is trying to reduce what we call the undifferentiating heavy lifting, and trying to provide you, let's say, a system, or better, a strategy that enables developers and also organization to design what, let's say, team topologies preaches, or the idea of having streamlined teams that are focused on generating value for the users or customers, depends from them. And removing let's say, the complexity around defining the network, auto-scaling, and all the other things that usually we do when we think on other type of compute services or database, wherever, and trying to minimize basically the effort for the developers, obviously giving some jobs that are based on the workload that they are building.
Okay, so it's the idea of decreasing the technical complexity that the teams should work with in order to deliver the value faster. Okay.
Yeah, so if you think, for instance, for doing parallelism, when let's say a company builds a platform with other technologies, it's very often what the platform team does is trying to apply economy of scale on that. So what it means is basically say, okay, we create, let's say, this orchestrator for containers, and this is the way how you spin up a new endpoint inside your system, and takes care of identifying all the steps needed in order to make the developers more productive. So to focus on that. With serverless, basically, instead of having your own team, that, again, platform team we can discuss later on, I think is still a critical aspect inside the serverless implementation. That, by the way, doesn't have to be only serverless. A system can be, let's say, a mix and match of technologies that we use often to see. But the idea is that you have, let's say, the power of AWS that is seeing, let's say, quite a lot of customers worldwide, and all the best practices are built inside these services for enabling teams to focus more on generating value inside their organization.
Okay. So what is the exact complexity we're removing when we're going Lambda? Because networks are still there, right? You need still to think about the authorization, about the logic, and so on and so on. what is the complexity actually got removed by Lambda?
So on Lambda, for instance, the network is partially there. Yes, you need to think about how to define your IAM roles. That is, let's say, extremely important because it's a part of the security posture that you want to have. So understanding who can trigger the Lambda function, which service the Lambda function should communicate with. And I believe that cannot be abstracted. It has to be defined case by case. But when we talk about network, currently a Lambda function is running inside the VPC, that is virtual private network, that is, let's say, managed by the service team. The fact that is handling the auto scaling, so spinning up new sandboxes based on certain requirements. So for instance, the fact that you decide to use, for instance, Node.js or Python, and you don't have to patch every time the containers with the latest minor bug fixing version of that, let's say, runtime, is definitely something that is completely abstract to you. If you want to run the Lambda VPC attached to your VPC, you can also do that. But also in that case, despite defining your VPC, that probably is already done for maybe other purposes, you just have, let's say, defining which availability zone your Lambda function will run. And behind the scene, we spin up, let's say, a network interface that is communicating with the Lambda function that is running still in the VPC owned by the Lambda team. So on top of that, obviously, if you start to have a surge of traffic, we start to spin up multiple, let's say, sandboxes that basically are composed by the runtime and the code that you have written. In the case that you decide to use a containers image, we do even more because there are different level of caches that are applied into the system. So therefore, we are capable to say that if, for instance, you choose a runtime that is common and let's say identified by AWS, like to be Node.js or Python, the image that we provide by default for using a containerized version of a Lambda function, then probably many layers are already cached at the closest level that we can. So it's even faster sometimes. There were talks during the last reInvent where one of the community members in serverless shared his testing on containers and showed that the fact that obviously caching these different layers and loading the layers only when they are needed provide, let's say, a way faster, let's say, startup of a container. So there are a lot of goodness available there. Even, for instance, the availability zone, if you don't decide to go with VPC attached, they are selected by us, and every time by default we assign the workload to different availability zone in order to make your system more highly available. So there is a lot of goodness behind the scene that is taking off from your table.
Okay. So you mentioned like the 3 or 4 big points in serverless. So the first point, as I understood, was that you don't need to update your container every time, right? So if we can compare like Lambda functions deployments with container deployments, with the container you would need to update the base image, right, for your application and rebuild it every time when you want to update the dependencies. With the Lambda, you just don't think about it, right? The only thing you need to think is business logic and updating the logic.
There are some caveats on that. So if you are packaged, so Lambda function could be packaged as a zip, or it can be packaged as a container image. Obviously, if it's a container image, you are completely in charge on that. Okay, so you decide the base image and whatever it is. But if it's a zip, we will take care about the runtime, and therefore the runtime for minor and bug fixing version will be patched by us. For major version, it should be patched by you, because obviously when you move from, I don't know, Node 18 to Node 20 or Node 22 in the future, there are some potential breaking changes that you need to take care of updating, and you select when to update that thing.
Yeah. But you can just select that. So now that your function will run not with Node 18 but with Node 20, and that's it.
Correct. And you will deploy, and that we will take care about having, because we work always with the LTS version of the runtime. And therefore we know that there will be long-term support for all of them. So that's how we work.
Yeah. Okay. Yeah, another point you made was about leveraging different levels of containers, right? In my weekly newsletter, a couple of months ago, I mentioned this article about how Lambda actually took a look at the performance and figured that like 80% of the images that are being uploaded to Lambda are actually the same stuff. So you can optimize it. Can you please elaborate a little bit more? Like, what is the intrinsic magic there?
Yeah, there is a white paper was released, I would say November of last year, from our principal engineer community regarding the mechanism behind that. But the idea is pretty simple. So you have, let's say, different level of caches that are available, because it depends. For instance, if it's the first time that you deploy a Lambda function as a container and is available in a specific region, that will be on probably the, let's say, farther down the line cache that is available. But then obviously the more is used or the more layers are used, if you're using, let's say, as I said, a normal image that is available, like, I don't know, Node, Python, Java, whatever, you will be able to handle that very nicely, because some layers are already cached. Therefore, the only thing we need to take further are the cache related to your code. Another trick that usually we recommend is to not shift, let's say, the when you describe your Docker image, to not, let's say, move around, let's say, the base image and other things that are more stable, to keep them at the beginning of your manifest, and then keep, let's say, the things that are changing more often to the bottom, because then we can analyze and understand that those layers are always the same, so we can apply better caching mechanism into that. But in general, we have different level of caches that are operating at different AZs, that are operating in different workers, and different regions. And if we start to think about that, there are several talks online where we explain that when there is a request, there is a front end that is orchestrating and calling, basically creating assigning a job to a worker. The worker creates a sandbox, and then your code is running inside this sandbox.
So one second, you touched on this topic that you need to move the things that are changing in the container down below the Docker file.
Yes.
So does it mean that the Docker container itself, it aligns the data in the container according to the manifest? So the base image is like, I don't know, like first 50% of the container, then some libraries, another 25, and then your code 25. Is it true?
Correct. So basically, if we are capable to keep that part stable, we are capable to understand which chunks are already cached. And because of that, then it became easier for us to, let's say, provide a faster load, because we don't, we analyze and we see, oh yeah, still, I don't know, Python 3.11, whatever, available. So I already have this stuff in cache, so I don't have to take to a further cache, and therefore it takes longer for latency reason.
Okay, so that sounds like a huge improvement, even compared to the Elastic Container Service, right? Because there you're just running your containers, and in Lambda, you're essentially caching the big majority of the container itself.
Correct.
And yeah,
again, with the caveat, as long as a standard image. Obviously, if you create your image because you want something heavily optimized, then we need to load, unless it's already cached because you have a lot of requests inside the specific, let's say, region, availability zone, whatever. Then we need to retrieve every time. But
yeah, okay. I mean, in software architecture and solution architecture, what you typically do when you try to make a decision about architecture, you would go and see the alternatives and then try to analyze the trade-offs that you're making with each of the alternatives. Do you want to know how to design proper software systems? Do you want to grow to a senior or staff engineer positions? I developed a business-oriented system design course specifically to achieve those goals. We're gonna learn how to identify and gather the requirements and also prioritize them, how to address performance, security, reliability requirements, how to document software architectures, and how to make architecture decisions. The course consists of 10 lectures, 10 home tasks, and the final work. You're gonna receive the graduation certificates by the end of the course. All the details by the links below the video. So what you're saying basically is that, hey, if you rely on the base images, right, you can have a huge performance gain in startup type, for example.
Correct. You will have a performance gain for sure. Yeah. That's definitely one thing that you need to think about.
But that at the expense of standardization of images. So correct. Yeah, that's the trade-off basically.
Yes. Okay. But great. It's obvious that you can continue to do so. It depends a bit from your workload, because if you have, like, for instance, I don't know, a cron job that is running once per day, so probably also if you have the trade-off that you load every time from the colder cache, you don't care, because
Yeah.
probably it's something that is running overnight and it's not a problem. It's obvious that if you have like a website, I don't know, let's say one Amazon.com or whatever it is, like an e-commerce that is at specific hours where it's more often, then definitely you will gain a lot of, let's say, traction with this approach.
Okay. Let's talk more about the trade-offs when you're going serverless. So what you need to consider as a solution architect or, I don't know, staff engineer when you're picking up the compute for your solution, like what are the other trade-offs or consequences with going serverless?
But I think the one thing that usually, so if it's your first time, let's say, journey or workload with serverless, you need to think about quotas, because it's slightly different from what you had before, where you can say, okay, I over provision, oh, I can do this, I can do that. But you need to understand really how your workload works. Usually every time that I speak with the customer, the first few questions are around, okay, what are your SLAs? What is your traffic pattern? How many transactions per seconds you have? Stuff like that. Because obviously you have a lot of stuff that is abstracted to you, and there are some tips and tricks that you can apply in order to make your system working. But very often I've seen that in the past, and I was guilty as well in the past, that when you have like always one way to express yourself inside an architecture, vast majority of the time you have point-to-point APIs everywhere. When you have the possibility of choice, where you start to look into, okay, should I really create a point-to-point or a synchronous API for this specific feature or not? And I've seen that enable us to, in the past when it was customer AWS, to design differently our APIs, and sometimes providing just an acknowledgement to the client, and taking and reducing the strain towards the rest of the system, because we had a very spiky traffic. We moved like from 10,000 users to 2 million in 1 minute. So as you can imagine,
oh my god,
yeah, exactly. For that minute, you need to be extremely ready. And therefore, we had like a good chunk of our services. I would say 50% of our architecture was serverless, and it was, let's say, 2016. So it was early days of serverless that there aren't all the goodness that we have right now in 2024. So I think it's just, let's say, a bit of shift of mindset that you need to apply, but starting with quotas, starting to understand what are the limits. And bear in mind, the quotas are vast majority of the time are soft limits. And therefore, you can just cut a ticket to the support team, and they will happily increase it for you.
By the quota, what do you mean? Like what exactly?
So, for instance, by default, because we were talking about Lambda, by default, you can spin up simultaneously 1,000 containers per region, and that means obviously if you have, like, say, let's assume a response time of 1 second per Lambda, so therefore you can have 1,000 TPS inside that workload. Obviously, this is a soft limit. Therefore, if you say, oh, by the way, I need 5,000, we will happily provide you 5,000 within reason, obviously. The thing is, if you start to say, okay, I need 1 million, then you need to provide justification on that, because we need to understand why you need 1 million. Because maybe the reason is not that you need more compute, but the reason is that you didn't optimize your workload. So we need to understand where the things.
The customers frequently understand what is the workload part and what are the SLAs.
I would say that it's 50-50 in my experience, but I think it's important to understand, let's say, that the traffic pattern is easier to a certain extent, because they know, for instance, if it's an e-commerce, they know that when is Black Friday, they are going to have quite a lot of traffic. They know, for instance, if it's live sport, that at the kickoff of a match, you're going to have a huge surge. Stuff like that is easy. For the SLA, often or not, let's say sometimes it's 50%, I would say, are defined or not. So what's the latest that you expect? What is the response time that you want to have? Very often, the answer is, oh, we want the fastest one ever, but we need to start.
Oh, that's classic. Yeah,
it's deeper in that case, right?
Yeah. What availability do you expect? Like 100%? Really? Why?
Yeah. I mean, sometimes there are obviously use cases that requires that. I was working as a customer in 4 region active. So we had like East Coast, West Coast, Frankfurt, and Japan.
Okay.
And this was needed because the latency for us was meaningful, extremely meaningful. Because when you do live sports, you want to have, let's say, a response time that is immediate, because otherwise you cannot delight your customers. And therefore, for us was like quite important. But sometimes you do that more for, I don't know, for failing over, for resilience, more than for latency. So it's completely different architecture you're going to design over there.
Yeah, exactly. So it's different business drivers and different requirements that drive the architecture solution.
Absolutely, always. Yeah, for me,
Okay.
when I start to engage with customer, I always start from understanding their context, their business requirements, and
True.
try to clarify them. Because with that, it's way easier to say, oh, probably considering your context, is better you use this service over the other service.
Yeah, exactly. Okay, yeah. What I want to add just right now is that I actually have a course, like business-oriented system design course, and literally the first lecture is understanding the requirements, like how to gather them, what the different types of them, how they drive actually the architecture decisions, and so on. So that's nice. I will attach the link down below the video, so you can check it out. Okay. So again, what you're saying is that business requirements and the situation and the load profile actually triggers those architecture decisions, and then you need to understand how, even if you decided that you're going with serverless, like what is the setup you have, right? So to many people, serverless or like Lambda functions are just the abstraction that, hey, I will just put my code and don't bother anymore. But they're actually like a reserved concurrency thing, right? So how do you think about the functions in the first place? What is the correct mental model to employ when you're thinking about functions?
I would start from the idea that first, you said correctly, so we need to start from the business requirements. Let's give, let's say, a concrete example, just to give you how I would think about this. So let's assume that you need to build a gift code API, okay? So gift code, what you need to express there is you need to check that the gift code is available, is not already consumed by someone, and then you need to notify probably a bunch of teams inside the organization and even outside if you have physical cards, for instance. And in that case, if you think about that, there are different requirements on how you need to notify them. Maybe it's a CRM that has, let's say, limited throughput. So if you have like 1 million of requests for consuming your gift code, you cannot, let's say, redirect them all 1 million requests into the CRM straight away, right? So you need to think about that part. If it's a third party, you don't know what is their throughput, but it's very likely that will have some limit. If it's an internal system, maybe you start to think about, okay, so can I have like maybe a queue that I can use? I can send events to them. Let's understand that. But the other cool thing of all of this is that what happens if I have 1 million requests coming in, but the reality, in order to notify my CRM, it could take like 1 minute or 5 minutes or 10 minutes, depending from what you decide to have. And even the third party, probably you don't have to do that synchronously immediately.
Yep.
And that, let's say, start to figure out that, okay, so how do I treat this workload? Because creating 1 million of requests that are coming into a system for consuming a gift code, we can define, let's say, with the memory cache and maybe with an API gateway and Lambda function, you can receive, let's say, we can design something that is extremely quick and absorb this 1 million requests per second. But on the other side, you don't have to be synchronous, and therefore you can design these things maybe using, I don't know, events, and say, okay, I collect everything that is changed inside batches, and I send this through event that start to communicate in different parts of the organization, and that start to make your life way easier, because you don't need anymore to say, oh, I have 1 million, hang on, I need to put everything in memory on a database and then analyze all this stuff and saying, okay, so let's take the last 10 records that were, or last 10 gift codes that were created, updated, whatever. And then I start to send them through APIs to others and request on the other teams to prepare that. It could be that you already have some API defined from a third-party system or from the CRM, or you can ask to the internal team to create a queue for you, or, it depends what are the possibilities inside the workload. But as you can see now, instead of thinking, oh, I need to do everything synchronously, that requires obviously quite a lot of logic. And if you think about also the load testing, end-to-end testing and everything for absorbing all this stuff, it's not an easy task. But if I can break down the problem into small chunks and apply the right architectural decision into that, now it becomes very easy.
Okay, so I don't really get the point. So what I got is that we have 1 million requests. We have understanding that it's not required to proceed them like all at once synchronously. But how it helps to build the mental model about serverless?
It helps because then you start, when you define your design patterns that you want to decide. So for instance, we were talking about events, right, before. Yeah. So if I say, okay, I need to have an event, we have a serverless service like Event Bridge, for instance, that enables you to send the events to multiple AWS services or to API destination. And that is built in. You don't have to write code for that. You just configure the service for that. And then slowly but steadily, you start to build this thing that not everything has to be a Lambda. There are other serverless services that enables you to plug this system, because when you think about modularities, it can be expressed in different ways. It can be expressed through code in your design pattern, in your framework, or it can be expressed through services. And in that case, it's just exactly the same thing. And that's why I'm starting from what you need to express, because the mental model should be, I understand what I need to do. I understand what are my boundaries and guardrails for this workload. So now let me try to modularize in the way that
okay. Now I get it. So now what you're saying, now what you're saying is that, okay, you have a business task, okay, of proceeding like with a huge workload. Then you understand how you can do this in like without attachment to the technology itself.
Correct.
Right? You're just saying the business block. So here are the compute, here's the queue, here's the handler, let's say, or like destination, downstream system, and so on. And then you can see what are the offerings of the serverless that you can apply in those parts, right? So here a queue. Okay, what is the serverless solution for that? Event bridge. Here's I need compute. What's the solution for that? It's Lambda. Then I need a storage for that. What's that? It's S3 buckets. And so on and so on. Okay, great. Now I understand the line.
And bear in mind, not everything must be serverless, because you can have easily, let's say, a mixed approach where you say, okay, so this part of the system, maybe having Fargate with ECS or having Kubernetes cluster is good, but more you move. For instance, for me, one mental model I usually apply when I was VP of architecture was everything that is at the edge of my architecture. Usually serverless is a great fit, because I have throttling, I have, let's say, API to merge, and they cannot sustain the traffic that I have. So therefore, working with queues, working with, I don't know, a database I store all the changes I need to make is very common. And therefore, they are serverless spot on, because when I have traffic, I pay for that and handle that nicely. I can handle everything in batches. And when I don't have traffic, I don't pay for that.
Yeah. Okay, great. So we started talking about other serverless solutions. So obviously Lambda is just one offering.
Yeah.
Like to me, S3 is kind of serverless because you don't work with the machines. Okay, just disks. Then DynamoDB is obviously a serverless offering, right? So what are other offerings that you can call serverless in AWS?
API Gateway is another one. We have SNF for messaging as pub subsystem. We have SQS for the queues. We have EventBridge for, let's say, as another system that enables you to connect, because usually SNS is the vast majority of the time is for fan out patterns. So I want to, let's say, communicate to multiple queues, these things, and SQS SNS is a great combo. EventBridge is instead for events, and therefore you can use nowadays cloud events. You can use, let's say, normal events. Obviously, cloud events is not natively implemented, but we have a way for you to use EventBridge with cloud events, and there is that native integration with many of the AWS services out there. You have also, for instance, the possibility to call an HTTP destination out of the box with authentication. So there are a lot of, let's say, goodies that are built into EventBridge. You can archive and replay your events if you need it. So a lot of, let's say, great stuff over there. We have also AppSync for managing GraphQL implementation. So there are a lot of, let's say, you mentioned DynamoDB, that is another great example, but there are many of services that are available in AWS that try to abstract basically the complexity for you.
Okay, so does it mean that you can build the entire solution just using the serverless components? Okay.
There are customers that are doing that, and there are customers that are using a mix. In both cases, for me, those are tools, right? So that's why I spend time, and I think you rightly said at the beginning that if you start from the business requirements, then you map them into your architectural constructs based on also on functional requirements that you have, and then you can start to map that into services. But I think the first two phases sometimes are overlooked or not taken too seriously in certain occasion, because we think that distributed system means that we don't plan anymore, we just go with the flow. That is not the case, because if you understand what you need to build, then it becomes way easier the implementation phase.
Oh, that's true. This has happened so many times. Like when people started adopting agile thing. They said like, hey, no designing upfront, screw that, we're just iterating. And then 6 months later, they're like, oh my god, what we built, we need to redo everything completely. And then what I like is Simons Brown, I think it was his saying like, hey, we need some design up front, just not the full, but some. So let's have a trade-off again, right? So yeah, good. Let's transition into this topic of the future of serverless technologies. So right now, what I see is that we can abstract a lot already, and basically, if you're just a developer who knows how to code, but you lack this SRE skills, like how to run the servers and how to manage networks between them and so on, serverless can be a great choice because it allows you to build a product and put it out there in the market for the test relatively quickly, right? But what is upcoming for us? Like what's in the future?
Serverless reached maturity, as we said at the beginning. It's 10 years old now, and it's starting to, let's say, consolidate. And we are working hard to listen, obviously, to our customers and understand what they're looking for in order to make more use of serverless inside their workloads. I believe that one thing that we need to, let's say, help our customer to wire their head is around the platform team. So you were mentioning you don't need SRE skills. Yeah, potentially, but we still need platform team that instead of focusing only on, let's say, the infrastructure part, they can start to focus on other important tasks. If you think about, for instance, developer experience, that is, in my opinion, the missing piece in many organizations, that they just create like a platform team, but they are completely unaware of how the platform is used. Having a developer experience team, usually it helps to bridge this gap. And also the cross-cutting concern, like I want an entry point for my APIs that is unique for everything. I want to log all of that. I want to consolidate logs across the platform for maybe the support team. I want to have, let's say, the cross-communication between the communication between different boundaries using, I don't know, Kafka or even Bridge, whatever. So all these cross-cutting concern has to be taken into account by the platform team in conjunction, obviously, with security architecture if there are these teams. But I believe the platform team plays a vital role in this implementation, because at the end, serverless is a tool that you can leverage, and that, yes, provides some benefit of abstracting certain things, but it doesn't mean that solves every single thing. If you think about API portal, stuff like that, so there are plenty of topics that the platform team is still in charge and can focus while he's using serverless.
I will now treat it as a treason, right? So you said there are no serverless, but then now you need a platform team to support it
for enabling the others. Because if you think about that, also if you have, let's say, an orchestrator for containers, it is not enough. You need anyway the way how you store all the APIs, how you discover your APIs. You need a way to just create templates for a quick spin up a microservice. There are bazillion of activities when you work in a distributed system, especially mid-size or large organization, that you need to take into account.
Even if you're starting small, like even if you have like, I don't know, 3 developers, and then you work on 5 parallel Lambdas, then you need already some unification around those. Like, for example, common layers, like common domain model, common things that you do, like how you do authentication, how you do observability things, and so on. So like I understand very well that you require this platform thing, right? At least to a certain degree. The problem is that the perception is like, it's serverless, I don't need to do anything, but actually you do, even there. So
we already, let's say, removed and abstract quite a lot of work to a certain extent, and obviously starting to optimize, like we discussed about how we handle the containers and the caching of containers in Lambda. So there are a lot of, let's say, goodies that are there that maybe you will never reach in other platforms that you built in by your own, because you have other priorities, obviously, not because you are not capable. But I believe that that you need to leverage what is good on serverless, but not saying, oh, I use serverless, I forget about the rest, because it's not the case, right? So there is a ton of other things that you need to think about.
True. Yeah. But let's get back to this topic of the future of a serverless. So you said you're consolidating everything. What does it mean? Like, what are the particular developments?
Yeah. So we know that we have, let's say, time to time some gaps on certain services, and the customers are rightly so raising the request, and we are feeding our service team to, let's say, what the customer would like to have. So the service team then is evaluating the request, and then then start to create the roadmap for specific service. So we are going to work, let's say, towards this consolidation. Obviously, currently the roadmaps are not public, so I cannot share too much about what's going to upcome, unfortunately. But I can guarantee you that basically what is in the roadmap is what our customers are asking for. It's not, let's say, some ideas that we come up with.
Okay. What is the vision for the serverless? Will it become a default option? Like, hey, start with that and then move to, I don't know, to Kubernetes or to ECS or to virtual machines later? Or it will be just one of the offerings that you give to the customers?
Usually we suggest to start with serverless because it's if you want, the easiest way to build on the cloud, because we have already quite a lot of, let's say, stuff defined by us and abstracted by us. Otherwise, there are way more decisions that you need to take into account, especially when you do a modernization or a migration or stuff like that. Obviously, it's not always possible. Therefore, maybe you need to do a lift and shift, and you need to move from, let's say, on-prem to the cloud, and you want to just move the system. So, but in general, for me, what I've seen as first-hand experience working for a long time with serverless and containers is that enable us to, when applied, let's say, properly inside your system and understand what you need to express, to really have a fast, let's say, production time for our APIs, and also enable the developers to express really what they need to do and tweak, modular, and change and evolve part of the system based on the requirements that were upcoming.
Okay. So serverless is becoming a default option right now. Yeah, I agree a lot, because the most important thing for a startup, for a new company, is the time to market and the ability to iterate fast and try the ideas. And like, people who are starting with Kubernetes always amaze me. Like, you have 2 developers? Really? You need a Kubernetes now? Okay. Good luck with that.
And I think it always depends what you're aiming for. For me, I always had a very pragmatic and lean mindset as architect, where I prefer that we tackle the problems that we have right now, and maybe adding, obviously, headroom and providing the non-functional requirements that are important for our system. But I need to understand the system before defining the technology, because otherwise the technology by itself, if I do the other way around, I might over-engineering stuff, and that might be a risk. I think with serverless, we take a bet back in the days when we started in 2016, and we won that bet because we were able to migrate, let's say, stuff from Lambda to containers, sometimes vice versa, and we were able, let's say, to leverage the modularity, because that's the key characteristics that you want in distributed system. You want to have a modular system that allows you to evolve alongside your business. And with serverless, considering you express a good chunk into your services and not in code, then it became, let's say, easier, not easy, but easier to change a service for another one, as long as you have done properly your code design.
Okay. Yeah, another question I had about serverless is about how do you think of observability in the serverless environment? Because with a traditional setup, you need to monitor for CPU, you need to monitor for disk usage, for other stuff. Like, how this view changes when you have serverless, when you have Lambdas?
Yeah, so in that case, you look into mainly logs, metrics, and tracing. Those are the 3 things that you look at. You look, for instance, in the case of the queues, how big. So imagine, for instance, you have a dead letter queue, and you want to understand when you need to do something. Could be like waking up the team at 3 a.m. in the morning, or doing a redrive of these messages that didn't pass through on the first attempt. And then you look into the depth of the queue, for instance. So it depends from the service, to be honest with you, to understand, let's say, how to behave, but you don't have, let's say, the complexity on saying, okay, so I have this specific workload on the container. I need to check that when it reach probably 75 or 50% of my CPU, I need to spin up another, 3 containers, whatever it is. So these kind of things are fading away for you, because you don't have to take care about that part.
Okay, true. So basically, the observability shifts with serverless to more business metrics rather than technical ones. So it
logs, metrics, distributed tracing is technical, logs still technical. The business metrics definitely useful, and then you understand how you want to behave on the system.
Yeah, true. A separate question: when CloudWatch is gonna have the functionality of searching inside the logs, rather than just searching by the title of the log group?
And you can search if there is an error. I was like literally doing yesterday night one example. I was preparing an example for a POC I'm working on for searching for errors or whatever. You can currently, if you look at logs inside, you can query and check if you find, give me all the logs that has this specific thing.
Oh, really? Okay, I need to check it out because typically you would go into the particular log group, into particular log, and then you can search, but not all the log. Okay.
Logs inside basically allows you to select one or multiple logs group and provide a query and say, okay, I want to see all in this logs group. I want to find all the, I don't know, error messages. So you go there, or the one that contains this specific parameter, and is checking inside your query.
Okay, great. Okay, I think a couple of last questions. So the first one is, what if I don't know about serverless anything? What is the single idea I need to definitely understand to start diving into the thing?
That serverless is, let's say, for me, the key idea that as an architect or staff engineer is that you need to think about it in the same way that you're thinking any other, say, construct or tool that you're going to use. It's just the modularization that changes, that shifts from I write everything leveraging the modularization expressed by a framework to I can express my modularization into services. When you start to, in my opinion, to link that your mental model, your patterns into this approach that is not anymore I need to code everything, but I can leverage a service to express a portion of what I need to do, then for me, that is the thing that triggers me to, let's say, design serverless workloads properly.
Okay, thank you very much for that. Yeah, that's a great insight. And the last question then, what is the best way to learn serverless in 2024?
There is a website that is called Serverless Land, and serverlessland.com, and is owned by our developer advocates and by the community itself, because very often there are a lot of design patterns created by the community and by customers that are, let's say, we are collecting everything there. You have guides, you have videos, you have a lot of patterns for quickly spin up, let's say, an API or a connection to, I don't know, Kafka or whatever it is that you want to do. And there you can find with different infrastructures code. It could be Pulumi, it could be WSM, it could be CDK, it could be Terraform. And you can contribute as well, and you can open a PR because everything is public in GitHub. You can add a new patterns if you feel that is missing currently. But there are a lot of great stuff over there.
Okay, thank you very much. Let's wrap up then. I learned several new things today, so thank you very much for this.
Thank you.
Yeah, so folks who are listening to us, thank you very much. See you soon, because there are several new interviews upcoming on the channel. So see you later. Thank you, Luca, very much. Have a great day.
Thank you for inviting me.
Yeah, thank you. Bye.